Hello everyone, welcome back to my YouTube channel. So in this video, let us discuss about the types of control systems, which includes open loop control system, closed loop control system, and whatever the classification that I have mentioned in a previous video. So we are discussing about that now. So now can see open loop control system. In general, we can call that as OLCS. Can observe the block diagram. The output is not depending on our input here. So whatever the input you can give, the response of the system which is same, it is not affecting with respect to the input. That is nothing but the system in which the output has no effect on the input are called open loop control systems. Whatever the input you can give, the output it will do its own work. You cannot change the output by varying the input. So that is what you can call that as open loop control systems. So here, the output which is not compared with the reference input in the presence of disturbance. If there is any disturbance which will be occurs in a system, the open loop control system will not perform the desired task. The changes in the output are corrected by changing the input manually. It will be not automatically changing the output with respect to input. Okay. And if the relationship between the input and outputs are known, then only open loop control system can use. The best example for this is a washing machine for open loop control system. So you are setting the time period for the washing machine. You just turn on the washing machine. Will be waited for 15 minutes. It will give you the output. The what will be the output of washing machine? It will wash the clothes. It will rinse the clothes and it will give you the clothes. But it is not depending on the cleanliness of the cloth. So it will not thinking whether the clothes are clean or not. The washing machine duty is to wash, rinse, and giving you the clothes back in between 15 minutes. Whether it is clean or not, it is not depending. So that is the best example for open loop control system. So that you can see the examples for open loop control system, the output is not depending on the input and you cannot control the output with the help of input automatically. So the best example, as I told, the washing machine. So in the washing machine, we are just doing the what soaking, washing, and rinsing in the washer that operates on time basis. You are setting the time for a washing machine. Either it has to run at 15 minutes, a quick wash, or else 30 minutes, whatever it is. It will do soaking, washing, and rinsing in the washer, operates on a time basis, but the machine does not measure the output signal, that is clean lines of the clothes. Clean lines of the cloth, it is not depending. You are setting time period. It will give you the clothes by soaking, washing, and rinsing. But it will not worry about the clean lines of the clothes. So that is what I can call that as open loop control system. Another one is traffic control system. Again, you are setting time for red, yellow, green. It will be operate on the basis of the time basis period. Again, it will not depending on the density of the vehicle, so it will operate if you set a time. So you can control this with the help of closed loop control system. We'll discuss that later. Similarly, you can see the one more is a room heater. So if you set a time period for the room heater, it will maintain the same temperature, as well as it is not depending on whether it is rainy season, summer, or winter. So a typical room heater is the best examples which are for the open loop control system. So that just see once again the open loop. Now we can understand the system in which output has no effect on the input and the output not compared with the input, and if there is any if there is any disturbances, the open loop control system will not perform a desired task. For example, the change in output can be corrected by changing the input manually. The examples: washing machine and traffic control systems and room heaters. So coming back to the advantages, so it is a simple in construction. If the construction which is simple means obviously the cost which is less, so that the less expensive. So if there is a less cost, simple construction, obviously maintenance is easy, so that it is economically not feasible. Back to the closed loop control system now. You can see the parameters what and all it has. For closed loop control system, it has an input, controller, plant, feedback, elements. So in general, I will tell you, if you are controlling a particular system, plant is nothing but a system, or else you can call that as a motor, as well as if it is a electrical case, any of the system. You need to control the system. So by comparing that, for example, if I am taking a motor, suppose instead of plant, you are controlling the motor parameters. So what you can able to control? You can control the motor current, torque, as well as the speed torque characteristics as well as. For example, the motor which is running at 1500 rpm, so the output should maintain the same 1500 rpm output. If there is a change in speed, instead of 1500 rpm, if the output of the motor is 1400 ampere, sorry 400 rpm, in that case, what feedback element will do? It will it will uh, it will check the output. If there is 1400 rpm instead of 1500 rpm, it will trigger and it will collect. There is a difference of 100 rpm in a motor, and it will collect that signal and giving to the comparator. Error detector is nothing but comparator. So this error detector will take a error of output of the motor, that is there is a 100 rpm speed differences, the motor is running at 1400 rpm. It will collect that and it will check the input. With the help of input, you are setting that back to the 1500. By varying the voltage, you can vary the speed. By increasing the voltage, you are correcting the signal, so that the error signal which will compare the reference input signal and the feedback signal. If the error between reference input and feedback signal which is zero, then the controller which will give signal to the plant, and the plant which will be operated at 1500 rpm. Plant is nothing but motor. So if you want to understand in Kannada, suppose ಇವಾಗ ಮೋಟರ್ 1500 ಸ್ಪೀಡ್ ಅಲ್ಲಿ ರೋಟೇಟ್ ಆಗಬೇಕು ಅಂತ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಡಿಸೈಡ್ ಸ್ಪೀಡ್ ನ 1500 ಸೆಟ್ ಆರ್ ಪಿ ಎಂ ಸೆಟ್ ಮಾಡಿದ್ರೆ, ಸಪೋಸ್ ಮೋಟರ್ ಔಟ್ಪುಟ್ ಏನಾದ್ರು 1400 ಆರ್ ಪಿ ಎಂ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ರನ್ ಆಗ್ತಾ ಇದ್ರೆ, ಇಲ್ಲಿ ಇರೋ ಎರರ್ ನ ಫೀಡ್ಬ್ಯಾಕ್ ಎಲಿಮೆಂಟ್ ಏನ್ ಮಾಡುತ್ತೆ, ಡಿಟೆಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಎರರ್ ಡಿಟೆಕ್ಟರ್ ಕೊಡುತ್ತೆ. ಎರರ್ ಡಿಟೆಕ್ಟರ್ ಅಂದ್ರೆ ಕಂಪ್ಯಾರೇಟರ್. ಇದು ಏನ್ ಮಾಡುತ್ತೆ, ಇಲ್ಲಿ 100 ಆರ್ ಪಿ ಎಂ ಕಡಿಮೆ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ರೊಟೇಟ್ ಆಗ್ತಿದೆ ಅನ್ನೋ ಸಿಗ್ನಲ್ ನ ತಗೊಳುತ್ತೆ, ಆಮೇಲೆ ರೆಫರೆನ್ಸ್ ಇನ್ಪುಟ್ ಸಿಗ್ನಲ್ ನ ತಗೊಳುತ್ತೆ, ಎರಡು ಕಂಪೇರ್ ಮಾಡಿಬಿಟ್ಟು ಬೈ ವೇರಿಂಗ್ ದ ಇನ್ಪುಟ್ ಯು ಆರ್ ಮೇಕಿಂಗ್ ದಟ್ ಆಸ್ ಝೀರೋ. ಅಂದ್ರೆ ಎರರ್ ನ ಝೀರೋ ಮಾಡಿಬಿಟ್ಟು ಕಂಟ್ರೋಲರ್ ಕೊಡ್ತೀರಾ. ಎರರ್ ನ ಝೀರೋ ಮಾಡಿದ್ಮೇಲೆ ಮೋಟಾರ್ ಅಗೇನ್ ರೊಟೇಟಿಂಗ್ at 1500 ಆರ್ ಪಿ ಎಂ, ವಿ ಆರ್ ಗಿವಿಂಗ್ ದಟ್ ಟು ದ ಕಂಟ್ರೋಲರ್ ಮತ್ತೆ ಸಿಗ್ನಲ್ ಕೊಡುತ್ತೆ ಪ್ಲಾಂಟ್ಗೆ, ಪ್ಲಾಂಟ್ ರೊಟೇಟ್ ಆಗುತ್ತೆ. ದ ಸಿಸ್ಟಮ್ ದಟ್ ವಿಲ್ ಆಪರೇಟ್ ಲೈಕ್ ದಟ್. ದ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಎ motor parameters. So in technical purpose, you can see the feedback control systems often referred as a closed loop control system. Okay, feedback control system or closed control system. And the terms closed loop controls and feedback control, which are used interchangeably. The reference input, you can see the input is nothing but reference input that corresponds to the desired output. So now we can control the output by controlling the input with the help of feedback elements. That's why a system that maintains the relationship between the output and the reference input by comparing them using the differences as mean of control, which is called as a feedback control system with the help of error detector. And the feedback path elements convert output to a signal of the same type as that of a reference signal. And the feedback signal is directly proportional to the output signal, and it is fed to the error detector. Means if the output system varies, feedback system also varies. If the output system is constant, feedback system is also constant, or else feedback signal is also constant. That is why the feedback signal is proportional to the output signal, and it is fed to the error detector. The error detector which will be act as a comparator, so that in this system the actuating error signal, which is the difference between, you can see, which is the difference between input signal and feedback signal, that is fed to the controller. The controller which modifies and amplifies error signal to produce better control action, and the modified error signal is fed to the plant to correct its output. Hence the plant which will be running at a constant operating parameters. If there is any differences, feedback element collect the difference, giving it to the error detector, and it will compare, and it will give zero signal or else zero error signal to the controller. Controller amplifies the plants again the plant which will be running at a desired output. Okay, the best examples for this now again the examples automatic iron box. Iron box it will maintain the constant temperature after a few minutes. That is with a thermostatic control and also automatic water heater. You can use nowadays the automatic water heater after 15-20 minutes it will be turn off automatically. That is nothing but when desired temperature reached, controller acts to switch off power to the heating element. And manual traffic controller based on the density of the vehicles you can control the traffic signals. Either you can set the red signal to the 30 seconds or 60 seconds based on the density of the vehicles as well as. Next, advantages. So accuracy, which is more compared to open loop control system, and also the effect of non-linearity and distortion, which is reduced and increased bandwidth. These are all the advantages. Comparison. So coming back to the comparison here, you can see the open loop systems which are simple. That's why it consumes less power. Here the closed loop systems which are complicated. That's why which consumes more power. And in case of open loop system, there is no feedback signal. So here the feedback exists in a closed loop. And in case of open loop control system, it is highly sensitive to the disturbances. The sensitivity of the open loop control system is more compared to the closed loop. The sensitivity of the closed loop control system is less, and the open loop control system, which is inaccurate and unreliable, but the closed loop open system is highly accurate and reliable. And the open loop systems are stable and less stable in case of closed loop control system. So as the system is simple, less power, less maintenance, which will be there in a open loop control system. I was not mentioned, you can write it. Maintenance is less in open loop control system, but the maintenance which is more in closed loop control system, and economical in open loop systems, and costlier, or it is much costlier compared to open loop control system. And the bandwidth which is less in open loop control system, and the bandwidth which is more in closed loop control system. So these are about the open loop and closed loop control systems. Okay. Similarly, you can see next the explanation of other classification. The first one is a linear system. A system that follows the principle of superposition is known as linear system. Superposition that includes two properties. The first one is homogeneity property. For the homogeneity property, you can consider example if there is an input of x of t which produces the y of t, then any constant that multiplied by the x of t that produces the constant that will be multiplied by the y of t. That is nothing but a is a constant. If x of t produces y of t, then if any of the constant a which is multiplied with the input, the output also produces by multiplying the same constant. And one more is additivity. If x1 of t produces y1 of t and x2 of t produces y2 of t, then x1 of t plus x2 of t additive that will be produces y1 of t plus y2 of t. And if there is a constant multiplication, if a is multiplied, a constant which is multiplied with x1 of t and x2 of t, the output that produces the same constant multiplied by the y1 of t and y2 of t. That is nothing but if x1 of t produces y1 of t, x2 of t produces y2 of t, then x1 of t plus x2 of t produces y1 of t plus y2 of t. And also a constant multiplication by x1 of t and multiplication of x2 of t produces the same constant which is multiplied by the y1 of t and y2 of t. That is a into y1 of t plus b into y2 of t. Similarly, nonlinear. If it is not following the principle of superposition, then we can call it as a nonlinear. That is nothing but a system that doesn't follows nonlinear, that doesn't follows the principle of superposition is known as nonlinear system. Similarly, time invariant versus time varying control system. Time invariant, it is nothing but when a parameter of control systems are stationary, it is not varying with respect to time. The parameters which are not varying with respect to time during the operation of the system is called time invariant. For example, if x of t produces y of t, then a delay in time, that is x of t minus t naught, that produces y of t minus t naught. In other words, we can call that as a time shift at input causes the time shift at output in case of time invariant control systems. In the same case, if we can consider, mm, if the parameters of control systems which are vary with respect to time during the operation of system is called time varying. Here the resistance, by changing the load, the resistance may vary, the current may vary in a motor. So that the resistance of the winding, if the current which is more in a winding, resistance will be less, so that the winding starts heating up. There is a possibility of damaging the winding. And also a fuel in a vehicle, whenever the vehicle which moves, the fuel consuming, so the fuel in a vehicle, that will be varying with respect to the speed of the vehicle. So that we can call that as a time shift at input doesn't cause us the time shift at output. We can call that as time varying system. Okay. And the next is continuous data control system and discrete. So in case of continuous data control system, here the signals at various part of systems are all the function of continuous time variable. Similarly, discrete data control system is which are the systems which are in the form of either a pulse or digital code. You can call that as discrete. And the requirements of good control systems. So it requires good accuracy, sensitivity, and external disturbance or noise should be less, and stability should be more, bandwidth should be more, speed should be more, oscillation should happen. So these all are the requirements of good control system. Very important, they asked many times in the examination to write the requirements of good control systems. So these are all explained physical system, physical model. Okay, so the next is mathematical model of physical system, we'll discuss in next video. Okay, if you're having any doubts regarding this, feel free to write in a comment box. I hope you are understanding the concept. If you really like this video, kindly share it to your friends and subscribe max. Thank you so much. Have a nice day.